4.5 billion years ago, our Earth was born from a mix of gases and minerals. In its early days, Earth was a lifeless inferno. Magma covered the Earth's crust. Eventually, the Earth cooled down. It is believed that asteroids hit the Earth carrying ingredients for life, such as water and organic compounds. Over the next several billion years, oceans and lands formed. Earth developed its atmosphere that would shield life from harmful UV radiation emitted from our sun. Just like any living thing, Earth itself has an expiration date, not to mention other risks that could end its life prematurely, such as climate change or planet-killing asteroids. However, in the present, the Earth faces much more immediate man-made threats like nuclear war. But what is certain is that our sun will eventually run out of fuel that all life depends on. As our sun depletes its fuel, it will start to grow, heating up the Earth, glowing blood red, and appearing over 3,000 times brighter. The oceans will start to evaporate. Forests will burn to ashes. Life, as we all know, will start to die. The sun, once the source of life on Earth, will be its executioner and eventually vaporize it to dust. Parts of our Earth with microbial life and other organic matter will be ejected into space and may begin life elsewhere in the universe. However, there is hope. Once deemed the end of worlds, nuclear power could end up saving all of life. With half-lives about 4.5 billion years, nuclear energy could power future spacecraft that could sustain life for many years to come, giving humanity time to find a new home. On this journey, much needed resources will have to be replenished, such as water, lithium, a crucial ingredient in batteries, and silicon, which is used in semiconductors that power most of technology today. That's where asteroid mining comes into the picture. With very little gravity, mining asteroids will be much more efficient relative to Earth. Asteroids will be the bedrock that could support interstellar travel. However, like any resource, asteroids are numbered. It's a lifeline with an expiration date. Humanity would need to find a planet to settle. This task would be one of the hardest humanity has ever faced in its existence, as the chances of succeeding are extremely small to near impossible. The task of identifying habitable planets in itself is a difficult process with a significant margin of error. The time and energy investment required for these trips would be astronomically high and make them strictly one-way trips. Given the low chances of succeeding, humanity will have to hedge its bets and send as many vessels to as many potential planets. To conserve energy, these vessels will be small, highly efficient, and will only carry material required to start a human civilization, with its most important cargo being human embryos. And the pilots will be the latest and most advanced AI humans have ever developed. The sheer distances between most habitable planets leaves a lot to chance, as many things can happen during the travel to that planet. Upon reaching their destination, the AI will analyze their planet's ability to harbor life and attempt to land on its surface. Some will succeed and some will fail. Due to the distances traveled and low probability of success, it is likely that any surviving human civilization may never come into contact with their own kind, and may even continue on a different line of evolution from other surviving human civilizations on other planets. Once again, humanity will wonder if we're all alone.